Good afternoon, everybody. It's not evening until after 6 o'clock in my world, so welcome to the first Green IT Specialist Group Fireside Chat between myself, John Booth, the Green IT's Vice Chair, and Jonathan Evans from Total Data Center Solutions. We're going to be talking in the main about sustainability and energy smart data centers. But before we start, Jonathan, can you tell everybody what Total Data Center Energy Solution does and some career background, please?
Yeah, sure, John, and thank you for the invitation to your virtual fireside. I started designing data centers, or computer rooms as they were then known, over 30 years ago, and I started my consultancy, Total Data Center Solutions, in 2002, working in Dublin for a new co-location company. It was only when I went to work with a new co-location company in Norway in 2010 that I started to understand the sustainability story around data centers. Green Mountain was a data center that was built next to a fjord in an old NATO ammunition bunker. And it was in fact cooled by the fjord. And of course, because it's in Norway, it was powered by hydroelectricity. So it was a very sustainable data center. But sustainability was not a big thing on the agenda in those days, and it was quite difficult to raise the profile of Norway as a data center destination and Green Mountain as a place to put your data. And things have changed dramatically since then, of course. I now work with several companies in the Nordics, including Eco Data Center and a company called Node Pole, who promote Sweden as a data center destination. That's where we are at the moment, John. Sustainability is back on the agenda and I'm enjoying it because I've been doing it for such a long time.
Thanks, John. A wide and varying career then, and we'll be going to some of that career during our chat. So I've prepared a couple of questions, and myself and John have been discussing how this format of this presentation and fireside chat's going to go. But before we begin, I would just like to wish Jonathan a very happy St. David's Day.
Thank you, John.
And obviously St. David was smiling on you guys on Saturday during the rugby.
Indeed he was, and so was the referee, of course.
Okay, so we've been carrying out a study for our client, actually. Part of our assignment was to conduct a sustainability benchmarking comparison against our clients' peers. And during our analysis, we discovered that there is no globally recognized definition for data center sustainability, although many operators cite sustainability in their marketing. So what would your definition be of sustainability?
Well, John, a sustainable data center is one that genuinely has no negative impact on the environment, potentially a positive effect on the global carbon footprint. Eco Data Center in Sweden is a prime example of that, and more of that later. Many data centers say they are green, in inverted commas, or sustainable, but run on dirty power using renewable energy certificates, or RECs. RECs are now considered low-quality products because they cannot credibly be used to back claims of 100% renewable energy use. For example, many German data centers use RECs from Norway, but the electrons powering them might come from a local gas or coal-fired power station. But to answer your question, there is no accepted definition for a sustainable data center at the moment.
Yes, and during our sustainability study, we did throw our net very wide and try to capture sustainability definitions for data center operations from around the world. And also, although there were a few potentially useful guidance or guidelines, there wasn't an actual globally recognized and accepted solution. So given that lack of definition, do you think that the standards development organizations, ISO, CEN and CENELEC ETSI, and perhaps the International Telecoms Union should collaborate on truly unifying the definition of a sustainable data center?
Of course they should, and that will be a great step forward, but one that would be difficult to implement, as you know, John. The industry would resist it, as there are very few data centers that are truly sustainable, and it's not good for their PR for that to be pointed out to them.
Yeah, I totally agree. I think there are some potentially big minefield to navigate in terms of data center sustainability. Yeah, interesting. So given that there is no accepted definition of sustainability, and we feel that the industry themselves would be a little bit resistant to actually defining one or and actually fulfilling it, given the recent EU announcement back in February 2020 that data centers can and should be carbon neutral by 2030, what's your opinion on that?
Well, it would be a great signal to send out to the industry, but in practical terms, quite impossible to achieve because the sources of power generation vary so much across Europe. 100% power from hydro, wind and solar or microgrids are the only way to achieve that possibly. I'm not sure where the atomic power from France sits on this in this regard. And of course, as the UK are no longer in the EU, they could take advantage of the legislation and directive and not comply with it and possibly have price differential as a consequence. So I think it's a great idea, but I can't see it being implemented.
Okay, well, that's an interesting view. I actually think that the EU are going to be really hot on this, and we're going to discuss the recently announced climate neutral data center pact as it stands a bit later on. Okay, so you're basically saying that you don't think it's going to happen, and I'm saying it probably will happen. So I'm going to answer my next question myself. So the next question is how should that manifest itself? Should there be a central EU Directorate General responsible for policing carbon neutrality by virtue of mandatory reporting? And should that apply to enterprise data centers as well? And for those that don't know, an enterprise data center is one that's owned and operated by the same organization. So think retail and banks. And a co-location data center is one where multiple clients can take space within that facility, which could be banks and retail as well, but it would be in supplement to their normal data center. Yeah, so John, carbon reporting, mandatory reporting, what's your view on that?
Well, most large companies are now providing detailed carbon reporting in their annual reports. Mandatory reporting of their IT carbon footprint could be included in that. The lines are blurred as so many companies outsource some of their IT to the cloud, of course. The hyperscalers are in fact doing a great job of reducing their carbon footprint, locating many of their data centers in the Nordics. But I think trying to define exactly what carbon footprint you have from a data center or the IT aspect of your business would be quite difficult.
Yeah, I agree. And I forgot to mention this at the start, but if any of the attendees have any questions, if you could please put them in the chat box and we'll get round to them when we finished the questions that myself and John are going to be talking about. So just put them in the chat box and we'll get round to them at the end of the formal questions. Okay, so so you feel that these companies should be doing carbon reporting, and I believe that many of them are. But I think from our sustainability exercise, we've discovered that they're not all reporting the same things. So one company is reporting to one recognized reporting scheme, and another company is reporting to a kind of another different reporting scheme. And it's very hard to actually get consistency and similarities across what they're actually reporting. So getting back to the EU again and saying, you know, they have basically said that they want all data centers and telecoms networks, by the way, to be carbon neutral by 2030. Do you and we've already discovered that we both believe that they should be reporting, but that needs to be tightened up, I think. But how about one organization mentioned to me privately that, you know, it's all very good the EU saying this, but, you know, are they going to put their hands in the pockets and provide money to improve legacy facilities? So do you think that legacy facilities should be provided assistance by the EU to improve their facilities to make them compliant with their new regulations?
It's a difficult one, isn't it? But I think they should possibly be allowed to assist legacy data centers, but of course they have very strict competition regulations in the EU, and sometimes they would find that they couldn't contradict themselves by helping to finance one data center company, and then that would be uncompetitive against another data center company. In general, I think it's a good idea. And as you know, I expect they already subsidize the 8 new HPC data centers that have been built across Europe through the Euro HP project. So yeah, in theory, it's a good idea to help the older data centers. But again, the reality might be quite difficult to achieve.
Okay, and what's your thoughts on what that assistant could look like? Tax brace on consultancy fees, for instance, maybe some assistance to purchase energy efficient equipment, more training subsidized by the EU via the local governments. What's your thoughts on that?
Well, I think they could engage specialist consultants because it's a very, very niche subject and a very specialist subject. I think every data center operator doesn't really have a full understanding of how to make a data center more sustainable. So consultants could advise and oversee the funded work. But of course, there'd have to be some sort of benchmark so that they can see that they're getting value for money in terms of the amount of carbon reduction compared to the amount of cost associated with it. And it's often very disruptive as well to an organization, because when you've got a data center running 24/7, to try and implement changes to the air conditioning or the structure of the building is very difficult and complex. So they might even resist accepting subsidies because of the upheaval it might cause their data center.
Yes, of course, the data center industry is the most critical of mission critical environments, also they would have you say. Anyway, so you mentioned earlier on in the introduction about your work with the Eco Data Center in Falun in Sweden. So
yes.
Can you tell us a little bit more about that particular facility?
Well, I've been working with Eco Data Center now for 3 years. It was in a startup co-location data center in Falun, which is about 150 kilometers north of Stockholm. The reason it's there is because green power is not available throughout Sweden. But in Stockholm, it's powered mainly by atomic power stations. And it's only when you go north of Stockholm that the power is actually fed from hydroelectric and green power stations. So that's the reason they chose the site after many years of investigation. And Eco Data Center have been extremely careful with site selection, which is a good lesson for everyone really, because the reason it's where it is because they could actually use the waste heat from the servers to provide local district heating and to provide heating for a wood chip plant that was manufacturing wood pellets not far from the data center. And the heat from the servers could be used to dry the pellets, and the pellets would then be used for heating in local homes. So they were very, very careful in the site selection. And then once they decided on the site, and it was obviously powered by green electricity, the next thing to do was build it. And they were very radical in their approach in that regard, because they built the data center out of wood. Now that may sound very surprising to everyone, but the sort of wood that they use, ProLam, is a high pressure laminate wood. And it actually doesn't burn, and actually structurally, it burns at the surface of the wood, but that forms a carbon layer which prevents the structure of the wood being burned. So I've been told that the wooden data center is structurally more secure than a steel and concrete data center. The other interesting aspect of it is that the wooden construction, they tell me that to replace all the wood that was used in the data center, it takes about 5 minutes of growth from the Swedish forests. So that's a truly sustainable data center, because once it's built, there is carbon built into the wood, which means that it's positive from day one, as opposed to making it out of concrete and steel. So yeah, it's a really interesting data center from every perspective, and now they're doing quite well with large corporates like BMW from Germany who want to try and reduce their carbon footprint and their power costs by putting some of their non-latency dependent data in a remote data center like Eco Data Center. So yeah, it's an interesting project, John. Feel free to contact me later if anybody wants more information on it.
Yes, and I believe your CEO gave a presentation at Data Center Dynamics last week.
He did indeed.
Okay, so John has sent me some slides from that presentation, but I can't put them on because I'm using a different PC at the moment. So feel free to go and visit the Data Center Dynamics website to download the presentation that Lars provided, which will give you some more information on what the Eco Center is about. I believe it's something called a gas bank or something.
It's very interesting and worthwhile trying to dig out the information, and I have the slide deck. If anybody wants it, just email me afterwards and I'll send it to you. Because Lars' background was he was an accountant, and he's been very, very specific in calculating the carbon footprint of Eco Data Center. He's gone into every detail, from the concrete slab to the construction, to the equipment that's on the site. Everything has been considered in great detail in order for him to confirm to everyone that the actual data center is climate positive. So the calculations are well worth looking at, and what he's done there is quite groundbreaking, because there's not any other data center operator that I'm aware of that has gone into this much detail. And he also has his eye on scope 3, of course, which is going to be implemented in years to come, where you have to consider the total impact of the data center, not just the input.
Yeah, that was going to be my next question. So we had a little bit of a debate about this one. So my question was, did you calculate the embodied energy of all the construction components, the concrete floor, the wooden frame, the electromechanical equipment, heat pumps and pipework, roofing materials, etc., etc., etc.? And John said, yes, see slides, which is okay. Yes, but I've had a look at the slides, and there are certain elements of that doesn't seem to be included, but that's a debate that myself and John will have offline. But I'm actually quite disappointed with a lot of data center supply chain, because data on the scope 3, the actual embodied energy within the components, simply isn't available, or it's not available in so far as you can actually go to the website, download a product sheet and see how much embodied carbon there is. But I do understand that there are a lot of organizations are now actively looking at this to try and get it published. The reason why I'm a bit disappointed is because it's been an EU code of conduct for data centers best practice for literally 10 years. Every time I talk about the code of conduct and I speak to guys in the supply chain at certain events, I go, what you're doing about your scope 3 and your embodied energy, and I just get this blank face and silence back at me. So I'm just going to give you an advanced warning. Many of you will know that I do I'm a joint author of the EU Code of Conduct for Best Practices. The 12th edition was recently published. If you download it and look at section 10, you will see that from 2022, life cycle analysis will be a mandatory best practice. So advanced warnings have been given. It's down to the supply chain to get their act together. So John, what's your thoughts on that best practice becoming mandatory? So it's the life cycle analysis. It's 3.2.4. Let me read it out to you before you make any comment, because it's probably quite important to get this right. Okay, so 3.3 is to introduce a plan for life cycle assessment in accordance with the emerging EU guidelines and internationally standardized methodologies. Example of this would be ISO 14040 and ISO 14044. Then there is a note in the best practice that said EN 15978, sustainability of construction works, assessment of the environmental performance of buildings, calculation method is also a standard that is considered relevant to this practice. Note, this practice aims to reduce overall carbon footprint and improve sustainability rather than directly improve energy efficiency. So, yeah, John, your thoughts on that?
Well, I think obviously it should be mandatory, and I'm not sure of this, but I think the French government are introducing some legislation around the EU Code of Conduct regarding anything that's provided probably to the French government, as data facilities. So yeah, I think making it mandatory would be a good thing. But I'm not sure that will happen in the near future. I think there is already a demand amongst the potential clients for co-location data centers to show that they're sustainable. And I think what we should probably do is get the potential clients to ask for it to be included in the package before they will respond to an RFP, for example, rather than at the moment they do consider, where the sustainability profile lies on a particular data center. But to actually have it as part of an RFP would certainly help progress it. The data center operators are now aware of this, and they are being told by potential clients that they must show their sustainability carbon footprint. And some of the hyperscalers are now not accepting these RECs and these other things. They actually are insisting that the power comes from hydro and from green power stations. So there is a pressure on co-location data centers to comply with sustainable aspects. And I guess there's no reason why you shouldn't just add that to an RFP as an adjunct to say that it's got to comply with the Code of Conduct.
Yeah, I would tend to agree with you, actually. In my opinion, we are facing climate change. We are facing some resource shortages. A ton of concrete will give off a ton of carbon. So and data centers use a lot of concrete. Your facility notwithstanding. Do you think that perhaps this should also apply to legacy facilities where perhaps accurate construction data is historic and therefore potentially unavailable?
That's a difficult one, isn't it? I haven't worked with any legacy data centers for some time, unfortunately, but I can see it being a huge issue to try and calculate when you've got a data center that was built 10 years ago. And obviously they weren't as concerned in those days about the carbon footprint anyway. That's just something that's come around in the last few years. So I can see that being an issue, and I think there'd have to be some flexibility in that regard, I guess. Otherwise they'd all have to knock down their data centers and build new ones on the site.
Absolutely. I think there need to be a lot of flexibility, actually, because whereas data centers built probably in the last 5 years, they will have access to the BIM data, so it may be relatively easy to extract from the bill of materials a true embodied carbon calculation. For older facilities that perhaps don't have those construction records available, there would have to be some flexibility, I think. Okay, yes, well, that's great. Yeah. Let's turn to energy. So many commentators have different views on the use of renewable energy for data centers. Some even go so far as to say, why just not data centers? Why? Surely every public building, such as hospitals, healthcare centers, government buildings, are more deserving. Why should data centers be using renewable energy? What's your view on that, John?
Well, I totally agree that all public buildings should run on renewable energy if at all possible. And I think we, as an organization, we've been joining different framework agreements which are issued by governments to assist in ensuring that they do lower their carbon footprint. It's not always easy to source green energy, though, throughout Europe, really, but in the UK in particular. So one option there would be to install microgrids, so you have your own generating plant on your own facility using solar and batteries. So to give you the on-site generation, and also we can have big multi-megawatt lithium-ion battery solutions now. And our company is actually installing a 2 megawatt lithium-ion battery on a data center in London, not a data center, a hospital in London at the moment, which will be powered by a solar array, and that will help reduce the carbon footprint of that hospital. So that's going to be a way forward for sure with public buildings and with things like hospitals where the electricity bill for the NHS is something like 50 million a year, I think, and I don't suppose a large proportion of that is coming from green energy. So yeah, I think it's a good idea to bring in public buildings, and we are pushing forward in doing that ourselves.
Very good. We did a recent CEDA assessment for an organisation which unfortunately I can't name, but they have a nearly a 300 kilowatt solar array on both their sites, both in Europe, one in Spain and one in Italy, which generates year-round power and is used to offset some of the energy that's required on site, not all of it, because obviously it's these are various basic, all good
What
stuff.
we're doing, actually, what I should have mentioned, is we provide these batteries with no capex and no opex, because the actual saving is about 20% on the electricity bill. And then we just split the savings 50-50 with whoever has the battery array, and it's paid for over a 10-year period. So that's a nice business model for somebody who hasn't got the capital, such as the NHS, to spend millions of pounds on lithium-ion batteries to try and reduce their energy bill.
Yeah, you're the second company I've heard of that does that. We're also debating a relationship with a company based near us, which does a similar thing. Only it's their funder that provides the capex and opex free. Well, capex definitely. So they'll go and install it on a lease basis. And that's something that many commercial companies can take up now. And in fact, my client uses their solution primarily to provide heating and power for a hotel chain.
Okay.
They're looking to get into the data center market with this unique, very similar model to yours, I should imagine. It might even be the same company. It means I need to talk to John about it. But I think it's a good idea that, of course, the problem is with data centers is that they like to have control of their energy, or feel they have control of their energy.
Absolutely.
But to be honest, they don't, do they? Because they're still at the whim of the generator and the grid. So if the grid goes down, then they're, just the fact that they have backup power is a good thing, and they've got the control of that, but they don't have the control of their primary power. This is obviously different in other countries around the world. Whereas if you look at the Uptime Institute tier topology, your backup or your generators and UPSs are considered to be the primary energy source with the grid as backup.
That's correct. Yes, I've had many arguments about that, actually.
Yeah. And unfortunately, there are many people within the data center sector that do not know about the standards and the tier topologies, but we won't chastise them for that. Education's a wonderful thing. By the way, we do training courses. Right, I'm going back to the Green Deal statement. Data centers can and should be carbon neutral. Do you think? Can you give us some insight into what you think that the EU think what that means?
Well, I just think it means having no impact at all on the environment, and better still to be climate positive, as eco data center is, where it's actually giving more back than it's taking out, according to the calculations anyway. So yeah, it's quite a simple term, and it literally is what it says it is. So I don't think people should have any confusion around understanding the term, to be honest.
And on the same note, and actually nearly our last question, what is an energy smart data center?
And now then, what is an energy smart data center? I haven't got a clue, John. It's got a lot of intelligence, I guess. So maybe you can tell us a little bit more about what an energy smart data center is.
Well, as you know, not yesterday, I've just had a text message from one of our delegates, actually, which I shall talk about in a minute, which is quite interesting. This last year, and from actually 2017, I was involved with the Catalyst project, which was an EU-funded project, which had 4 data center pilot sites, which were used to test out various scenarios, including district heat, energy flexibility. So what I would say with an energy smart data center is that it's a data center that sits in its local community, and it's a prosumer. So it's a producer and a consumer of energy, but it might well be a little bit oversized. And that oversizing allows it to provide energy to the local community, but also to provide energy flexibility back to the grid. So if the grid's having problems, it can contact the data center and say, look, can you go fully offline so that we can release whatever megawatts you're taking from us, and to distribute that to other entities on the network. Could be residential, could be hospitals, could be anything, for the duration of this period of emergency. And then what we'll do is we'll bring you back on as and when circumstances allow, and we'll pay you for that. And this is very similar to the store. It's like this, you know, short-term operating reserve mechanism that is being phased out by government, unfortunately. And one of the reasons for it being phased out by government was that it was deemed to, it had become uneconomic to do it. So before there was the carbon taxes, if you were on store, you could use your backup generation facilities to provide energy back into the grid. And it was a very lucrative little scheme that you could be entered into. Then what happened is that the carbon taxes started ramping up, and the profit of running your generators in line with store became narrower and narrower, until it came to a point where actually it was costing you more to be in the scheme than it was to be out of the scheme, because you if you took into account the wear and tear on the generator plant and the stop-start nature of it. So, but anyway, it's being phased out. I think it's being phased out, but I'm not quite sure. I need to check on that. So anyway, energy flexibility gives the opportunity for, say for instance, when you're on a backup, when you're on a mains test failure situation, you're actually doing a mains failure test, and you've got all of your contractors and staff available for you, and you switch to backup generators, that the energy that was coming into your data center, you sell back to the grid.
Yeah,
right? So and I'm sure you know a lot more about that. So tell us how your 2 megawatt battery and solar array works in the hospital.
well, yeah, I mean, essentially it goes into the main switchboard. So when electricity is expensive, which is between 5 o'clock and 7 o'clock, I think primarily, the batteries take over a large proportion of the load. And so the actual electricity consumed from the grid reduces dramatically. And therefore they're saving money by not paying the high prices that are charged during those hours. And then the battery is recharged during the night, or from a solar array, or from wind turbines, which we can also install on the site to charge the battery during the daytime. So that's essentially how it works. There are many other aspects to it which are quite complex in terms of how we get savings from the battery, but that's the primary way of doing it. And as I say, it's substantial savings to the effect that it pays for itself over a 10-year period, and the hospital or whoever saves 10% of their electricity bill, and it costs them nothing. So it's a win-win, I guess.
Yeah, good stuff. Okay, so I just right. Okay, John. So back to basically what we've been discussing all afternoon. When do you think that all data centers will actually be carbon neutral?
When indeed. I think the more of them that are moved to Norway and Sweden, the better, and then they'll all be carbon neutral. But obviously, you know, even now, non-latency dependent data can be taken to Norway and Sweden. Volkswagen have IT, HPC IT in Norway, and Iceland is BMW got it in Iceland. So there's no reason why companies can't put a lot more of their data in these places where power is cheap and green. It's much easier to transfer bits than it is to transfer megawatts down a pipe. because as you know, when you transfer megawatts, you lose a lot of energy in the transfer. So, you know, the more data centers that can locate in places like that, I guess the better in that respect. And those that can't, they just have to, they can even big data centers can fit, if they've got space, with large, very large arrays around the perimeters of the data centers and on the roofs of the data centers. There is one in the US now, Switch data center in the US. They're building 50 megawatts of solar panels in the Nevada desert and 50 megawatts of battery to support it. So there is no limit to the scale you can have in terms of these local power generation dedicated to your own data center. So I guess the more of those there are, and the more data centers are located in the Nordics, the lower the carbon footprint will become. I guess it'll never go down to zero.
Okay, that's very good. I just want to, our very good friend John Laban has been texting me, and he's saying that actually environmental product declaration sheets are available. And this is true, John. There are some companies that are providing EPDs. The majority of them aren't, unfortunately. But I'm sure that with the LCA requirement in the Code of Conduct, plus the fact I've been phoning around a few of them and saying, you guys really need to think about your EPDs, that we'll see a lot more visibility of EPDs moving forward, assuming, of course, that they've calculated them correctly. And John has also informed me, which I'm very excited by, but the new London plan available from tomorrow requires embodied carbon measurement. So that will be very interesting, and I will be looking at the information on the London plan as soon as it's published, which I think is a good thing, and that could frighten the bejesus out of many data center operators in London if they have to start doing that for their new facilities. Having said that, John, and we've got quite a bit of time left, so I'm going to go off reservation actually. I did a presentation last week, which I believe you witnessed or saw at the Digital Infrastructure Network, where I kind of mooted the point that actually there is significant problems ahead for the data center industry. And in line of the massive growth that's been published in various places of new projects, you know, there's 100 megawatts here, there's 100 megawatts there. India have just announced 6 50 megawatt facilities being built there over the next couple of years. I can't help but thinking that these are pie in the sky, because actually the grid capacity isn't there. And in my presentation last week, I'd done a bit of research, and in London next week or over the next 2 years, there's going to be 286 megawatts of power for data center constructions will be released. Yeah, they will be on live and line. But that's it then. In Slough and that area, there is no more data construction going to go ahead because the grid simply hasn't got the capacity. I looked at Amsterdam. Amsterdam had the moratorium on energy last year. We all know about that. It has been somewhat released, but there are still energy restrictions. You know, the Dutch government have a strategy where they've got 6 areas of the country which can be used for data center construction. Amsterdam Schiphol is one of them. Almere, which is to the north east of Amsterdam, huge area, reclaimed land. The grid there needs to be upgraded. The grid in Frankfurt needs to be upgraded, 850 million euros. The grid in Paris has a 4,000 megawatt capacity increase reputed as part of the Greater Paris Plan. So London, Amsterdam, Frankfurt and Paris, the flap markets, all facing potential grid problems. Then I thought to myself, well, I know, let me have a look at the COSH markets, which is Copenhagen, Oslo, Sweden and Helsinki. Oh, and surprise, surprise, same problems. Copenhagen, Dutch Energy Agency, their report, energy consumption for data centers in Denmark is subject to considerable uncertainty up to 2030. Oslo, all the grid in Oslo needs to be upgraded. Now, I'll come on back onto that in a minute. Stockholm, the grid needs to be upgraded. Helsinki, all of the generation sources are in the north of the country, and high transmission lines need to be installed to bring that power down to Helsinki, which is obviously in the south. So it's all very well saying that the Nordic grids are hydro and great, but they're not in the capital cities.
No.
And you have to move out, you know, bulk industry, Kristiansand, Fallon, mid Sweden, Boden, and Hydro 66 up in Luleå, Stavanger for Green Mountain, Copenhagen. You know, to be honest, can you name me another city in Denmark? And that's being facetious, I know. And Helsinki, you know, look at, you know, if you go to Finland, it's Helsinki. Nobody wants to travel up into the Arctic Circle. So I think my point is that the traditional flat markets and the COSH markets, they're all being mooted as great data center locations, but actually they come with their own problems, which is you have to wait for your grid to be upgraded. And I can't comment about India because I don't know what the Indian grid looks like or even how it works. I think it's done on statewide stuff, but it's primarily coal, right? So how can you be going out and pretending you're going to build 300 megawatts of capacity and spend millions and millions and millions of lakhs of rupees on building these data centers in a country that's 60% powered by coal? It's just, you know, it just doesn't stack up in terms of these countries' carbon commitments. Even in the States, I mean, we've only got to look at last week and the week before that, Texas, the power grid, right? You know, there are many data centers in Dallas, Fort Worth region. There's many data centers in Austin, San Antonio, all these places. The price of power last week went up to $9,000 a megawatt. That is $90 a kilowatt.
Wow.
How much is the normal grid value in Texas? I would suggest it's probably 9 or 10 cents per kilowatt, and it's gone up by 1,000-fold, hasn't it? Really, to cover shortfall stuff. And the other thing is, most data centers only carry 72 hours of diesel in their day tanks. They had traffic problems and roads closed for 4 or 5 days. You know, what was going on? And I think I read a report, I can't remember where though, but I read a report over the weekend, and it said that the power companies had no problem providing power to the city centers. So all the lights in Dallas were on, and in certain places like that, but they let their residential customers out in the sticks go cold, and literally go cold. And does that then mean that we need to think about the grid itself in terms of its reach and capability? What else is going to say? Right. Okay. Yeah. So that was my rant over. Right. It's just I think that some of these plans from data centers to build in certain locations globally, it's not just confined to the UK and Europe, but they don't seem to have been reading. They're not reading the room. The room is saying energy efficiency and sustainability, and they're going, yeah, man, but you know, to do this energy efficiency sustainability, you need us, and we need to build these huge, great, big, energy guzzling, fire breathing dragons to support the IT that you need to do your sustainability goals. And I would, you know, I've got a serious question about that. And when we are finally back to normal, and we go out and talk to people in the bars and the restaurants during the events, I'm going to be seriously asking people, you know, how can you justify your stance, saying this and doing that, and then saying something else? It's not right. Anyway, that's my rant over. So, John, we've still got plenty of time, actually. We've got an hour. Nearly got an hour.
I mean, just on the German market, there are people over there who are saying that they're shutting down the coal power stations and they're shutting down the gas power stations, but they're not building the green energy provisions that they need quickly enough. So there could be issues with power in Germany anyway. And obviously we have issues with power in the UK in terms of the frequency, because green energy is not as easy to control the frequency as the old gas turbines used to be. And so from that point of view, we also need the battery storage to try and provide some stability to the grid. So yeah, there's issues around power everywhere. Microgrids might be the answer to some extent, but that everybody has their own, as much as possible, their own power generation. That might help a little bit in terms of giving them, some sort of resilience against major power cuts. So yeah, it's a difficult one. What's interesting, of course, is that the governments now are all very, very keen for data centers to come to their shores. When I started in Norway, the Norwegian government wasn't a bit interested in data centers, but as the value of the oil fell, they suddenly realized they were totally dependent on oil and salmon, and they started to look around to see where else they could generate revenue, and so they became very interested in data centers, and Sweden the same, and also Denmark, of course, and they're all very, very keen now to try and get the data center market over to their shores. But yeah, I can see your issues around grid power, especially around London and around Slough. There's going to be massive constraints there. On that subject, I can just pop in a little ad for something that we're doing, which is immersion cooling. Now, immersion cooling is quite counterintuitive. I don't know if anybody's actually seen demonstrations of it, but it's like taking a chest freezer, filling it through with a non-conductive fluid, and then placing the servers into this fluid. And the fluid liquid is far, far more effective at taking away heat than air ever was, like 1,000 times more efficient, apparently. And so immersion cooling, it's been around for 10 years, but it's because it's counterintuitive and because we're a bit risk averse in our industry, it's never taken off. But I'm going to become a bit of an evangelist for immersion cooling in the future, because not only do you need less space and less infrastructure, so it costs about half as much to build a data center, but also the heat coming off it can be captured much better and can be there for use for the local district heating or whatever else you want to use it for. So that's my little evangelist prayer for tonight, is that people should look at immersion cooling. And it just reminded me of when I started in the industry, the big 3090 mainframes were all liquid cooled. It was the only way they could cool them, because they were getting so hot. So they all had chillers attached to them with massive amounts of cold water being pumped around the central processes at the time. So yeah, so that's my little advert for the evening, immersion cooling. And we're working with an American company called Green Revolution Cooling. We've been doing it for years in the States, but it's never caught on anywhere else. If anybody's interested in that, please get in touch, as they say.
Well, yes, thank you, John. I've been quite an advocate of immersed cooling myself for about 10 years, ever since I saw the first isotope prototype from our friend Peter Hopton. So, and that's actually a solution that's made in the UK. They're based in Sheffield. It's a very good solution. I think the add-on, the thing with immersive cooling is that, yes, in terms of capex, you don't need to have the chillers and the crack units, and therefore the pipe work for that. So you can take that right out of your capex equation. And then, of course, on your opex side of things, you're not using the energy to run the chiller and the crack unit, so you can take that out of it. And the heat that's rejected from an immersed cooling solution is considerably higher than an air-cooled alternative. And that heat is actually useful for district heating systems and other industrial processes.
That's correct.
Yeah, absolutely. We've written a couple of articles on called Air versus Liquid, which are available on our website, carbon3it.com, news and events. And I think it's on page 4 or 5 now. There's so much news and stuff coming through, but that site is quite helpful. It's got a lot of interesting stuff that we talk about. Yeah, of course, a lot of people get a bit scared of district heating systems and its integration with data centers, but actually it's because their view or their understanding of district heating is actually very 20th century. And they kind of think, oh, where would you see a district heating system that's actually in commercial use and is useful to the community? And of course, most of those tend to be in the Nordic regions. So I know that there is a district heating system in Oslo, there's one in Gothenburg, there's one in Sweden, I'm sure there's one in Fallon, I know there's one in Luleå.
Yeah.
So the thing is with those ones is they are high temperature district heating systems, and they need to be high temperature because the average temperature for Sweden is around 10 degrees C. So it gets a lot colder in the winter. It's down to -20 in some cases, even further than below that. You need to have high temperature district heating systems in those environments because heat, unfortunately, will diminish over time and distance. It's a standard physical property. You put a cup of coffee on your side table, steaming, within half an hour, it'll have got cold. Now, we know that energy can't be consumed, it just changes into a different form. So what that cup of coffee's done is heated up the air in your room. And, in places like Sweden, where you've got -20 for 5 months of the year, it needs to be high temperature because it's got a long distance to go. But if you start to look at those solutions in relatively warm countries such as the UK or even in Amsterdam or even further south, you can get away with medium temperature and low temperature district heating systems, which operate at temperature ranges that are considerably more aligned with the outputs of some of the immersed cooling solutions, around 55 to 60 degrees C. You can put them into underfloor heating, for instance. Most underfloor heating systems are 24 degrees. In fact, it make it a good use for air, but obviously the amount of air that you'd need is prohibitive. But with liquids, you can pump that around and put it under floors. And I believe there's some projects that are going on in the Netherlands where they're talking about putting that stuff underneath. But anyway, we've still got half an hour left, but there's one thing I wanted to advise the listeners about, and that's the fact that Euroheat and Power over the last 3 months have conducted some workshops with people from the data center community, and we've prepared a positioning paper which will be published to the EU in the next couple of weeks. And this is basically some of the things that we feel need to be addressed by the Commission in order for the real take up of data center waste heat going into district heating systems and how this can happen. So it talks about training. It's waste heat, actually, did you know, in the Netherlands is not, it's treated as an industrial waste. It's not on the renewable energy list. So you don't get any marks or scores or even incentives to use it because it's just not on the list. So as you said very early on today, unless operators have got a viable business case and maybe some subsidy, they're not going to do it. And this is why to date we've not seen any wide scale adoption of that. That's not to say that the Netherlands isn't a hotbed of district heating systems, because it is. The Equinix site, I think, in Amsterdam Science Park provides heat into that local district heating networks, and there are many projects. I'm sure my colleagues at the Dutch Data Center Association will be able to tell us more about that. In fact, I think there's a thing going on this week about that, but it's in Dutch. So probably, well, I've actually been learning Dutch over the last year or so. I've got up to about 1,000 words, but I'm not proficient enough to understand a technical debate, which I'm sure that one will be. So for the next, what we'll do is I'm going to open the floor to questions. So please feel free to ask any question you like, put it on the chat, and myself and John will do our best to answer it.
Yeah, while we're waiting for that, John, one of the things we discussed earlier on is the fact that co-location data center operators are very reticent to spend any money that they don't have to spend and introducing the waste heat from the servers to a local district heating system or anything else just adds cost to the construction. And that's what they're reticent to do. So maybe there should be some grant system around that. Either there need to be grant systems around it or they need to be forced to do it like there might be in Amsterdam. But yeah, you know, it's a very competitive market, the co-location business, and no one wants to spend any money that they don't have to spend. And that's one of the things that slows down the use of waste heat from the servers.
Yeah, I tend to agree, but you know, there are a lot of businesses that have to do things that they don't want to do because of regulation and safety regulations. So, and to me, this is just another. It's like part of doing business. You know? We can't have data centers putting waste heat out into the atmosphere and therefore warming the planet and using fossil fuels when we're in this climate emergency. Something has to fundamentally change. Now, I was on the Sustainable Data Center Sustainability Professional course last week, which was great. You know, there was plenty of really useful things that can be done that are BAU changes you can make, which are not capital expenditure or even operational expenditure. Just getting out there and doing things like putting blanking plates in, raising the temperatures a couple of degrees, looking at your waste, thinking about how you heat your generator blocks, looking at the eco modes that are active on the UPSs, you know, all sorts of really business as usual stuff, which data center operators do. The code of conduct for data centers, for God's sake, it's in its 12th edition. It's been out there for 12 years. It's got 160 plus best practices, which, you know, you can use to make your data center more energy efficient. But ultimately, it comes down to the risk profile of the organization. As I've mentioned on my blog and in presentations and debates that I've had over the last 5 years, use the code of conduct as a strategic cultural change tool, right? If you look at some of the best practices, it says in there, for instance, consider grid and virtualization, right? So for grid and virtualization, read cloud. So consider having a cloud first policy. And then it says, make it a requirement that if anybody wants to buy equipment that's not in your cloud catalog, have senior management needed approval to sign it off. Right? That's a very simple thing. Most compute is now commodity, right? You can get it in the cloud. If you don't like going to a public cloud, put it in your own private cloud. Buy a load of servers and create your cloud. Get some SAN, put that in. Don't let people have the ability to buy their own kit on their departmental budgets, right? That's what I mean by a strategic change is, you know, leave the purchasing of IT to experts and leave the management and operation of those equipment to experts, and don't allow shadow IT to proliferate within your organization. You know, one of the things they were talking about last week was the concept of zombie servers. Apparently 40% of the US server estate are comatose zombie servers. And that represents trillions of energy consumption that we are spending on powering something up that's just creating heat for ourselves. We really need to, you know, we need to be lean, mean, and green, and hopefully.
Sorry, not to interrupt you there. Another aspect of it is the actual IT equipment, as you say. You know, there's a company called IT Renew now, and what they do is they take all of the OCP Open Compute Project servers from people like Facebook who renew every 2 years, and then they refurbish this equipment and they sell it onto the market. And when you do that, it's a dramatic reduction in your carbon footprint, because I mean, obviously creating new servers is extremely difficult to do in terms of carbon, but to reuse an existing server that's just been refurbished is a great strategy. You know, and IT Renew are going from strength to strength as a consequence of it. So I would certainly suggest, if people are interested, to look at that company, because they are doing really well now, wasting on refurbishing equipment that would otherwise just be scrapped, I guess.
Absolutely. So we've got a question which I'm going to come on to now from Alex, which says, rather than building more data centers, hold on. He's asked two questions. So rather than building more data centers, where are we with using compute more efficiently? How much of these do we actually need and how will this happen? And I think where he's going there is, right, so the industry uses a metric called PUE, and it basically is the ratio of the power, the total power of the facility divided by the amount of IT. So what you're looking at is you will get a figure there which can be, it will be greater than one, always be greater than one. And in the most efficient data centers, like for instance, the Boden 1 DC in Falun in Sweden, that operates at 1.007. And that's because of where it's located and the fact that it's a really stripped down data center. Think this is like the Aero Atom, the car that Clarkson drove on Top Gear a few years ago, where his cheeks were being pulled back with the speed of it. Against a conventional car. So it means completely stripped down. It's like a go-kart of a data center. Up to some facilities that can either be 3 and 4 and even in some cases 10 PUE. The thing is that we have to concentrate on the one. This has now been promoted throughout the industry that the IT manufacturers need to get on board with looking at the one and making sure that the stuff isn't idle. So yes, Alex, it is in progress. I think some more work needs to be done with the ICT industry, and I think they're going to be under increasing scrutiny over the next couple of years. And
Shall I answer the next question for you? So I've got a bit of knowledge of it. It's what happened to the much hyped floating or sinking in brackets data center? Did it sink without trace? Actually, if we're talking about Nautilus in San Francisco, it hasn't sunk without trace. They are persevering with it. It's a data center built on a very large barge. And obviously, it's both sort of advantages in terms of the fact that you use seawater to cool the data center. And so they are pushing on with it. There's a company called Keppel in Singapore who are actually put some finance into it now. And Keppel in Singapore are actually considering building floating data centers in Singapore because of the shortage of land. Now you can use seawater to cool your data center very effectively. That's what Green Mountain did in Norway. They bring the water up from deep inside the fjord, and then they put it through a heat exchanger, and then the water is circulated around the data center with pumps, and it's a very, very efficient way of cooling the data center. So it hasn't sunk without trace, and there was some talk of one being put in a harbour in Ireland, but I don't know quite what happened to that. The one I think that should sink without trace is the Microsoft one, which is the one that's under the water. I really can't get my head around the point of that at all. I think the floating data center would work well in docklands where land is so expensive, and obviously if ever there's a potential for flooding in London, then the floating data center would float above it. So I don't think it's dead, but it's obviously like a lot of things. If you're a risk-averse data center operator, putting it on the water is probably not what you would like to do. But the applications could be things like emergency situations where you could bring a data center by sea to a site and set it up, that type of thing. Or as I say, somewhere like Docklands or Amsterdam, where there's a risk of flood. So it's not dead, but they are struggling a little bit. I think it's fair to say. So that might answer your question on the floating data center.
Yeah, it's Nautilus, isn't it? And I do believe they have got planning permission for a site to be at Cork in Ireland, actually in Cork Harbour.
Yeah.
And yes, you're correct. They are looking at Singapore as well, which they are constrained by their lack of land space. So most of the data centers in Singapore are actually quite high because they go up into the sky, and it might be useful for them to have some floating resources. I mean, to be honest, yeah, I mean, one thing to remember, and John, you know this only too well, the big, the people that make the decisions in our industry are very risk adverse. you know, and I am guilty of calling them hairy-arsed mechanical and electrical engineers that have made good. And I still think that applies to most of them. But I say that to their faces, John, you know, and they laugh because they recognise themselves, because they are people that have, you know, they are engineers. They've been there, they've built data centers, they've operated data centers. There are other skills, perhaps, you know, there's a couple of rough edges in terms of presenting and all things like that, but they are by nature conservative engineers, and they're time served as well. You know, they've done the tickets, they've got the tickets. They're always, you know, they're electrical engineers by trade. Some of them are professional engineers, some of them are chartered engineers, and you know, that's great. But they do have, with that experience, a great degree of caution, and that's something that, you know, I don't think we can accept for much longer, right? You know,
But don't forget their jobs are on the line if they get it wrong, though, aren't they? That's the thing. If you do something that doesn't work and data center goes down, you know, that's the intrinsic aspect of their risk averseness, so to speak.
I get that completely, but you know, I look at the code of conduct and I look at the strategic and cultural change, and you know, one of the best practices to do an audit and get rid of all those virtual zombie servers that aren't being used, right? So how often is that done? And then there's kind of like, you know, I'll give an example. So I did a big migration of a local authority data center from one data center to another data center, and the client's project manager raised to me that one particular server wasn't working, and I was basically looking after the migration, but I was also the standby engineer. So I think I started work at 8 o'clock in the morning and get back into the house until 2, and then I was called out because this server hadn't worked and I had to go back again. Finished about 6 o'clock. We replaced everything on that box. We replaced the motherboard, we replaced the chips, we replaced the memory, replaced power supply, the whole lot, right? And the only thing we hadn't changed was the disk, right? It's the only thing we hadn't changed. Anyway, so the next morning when we're doing the final bit, I said, well, I went to the client, I said, look, we've tried our hardest to get this box up and running, right? We have done everything to it. And he went, oh, yeah, I don't know why you bothered, because that box didn't work anyway. I'm like, okay, so it begs the question, why did you migrate it? Yeah. And you know, it's those sort of things that the code of conduct, if you use it correctly and you look at the management systems and you implement those, then you can look at your IT procurement, then you can look at your cooling, then you can look at your other power sources, monitoring, measuring, and you need somebody to guide you through it, right? And too many data centers are basically just going, oh look, blanking panels, I'll put them in. Oh look, raising temperatures, I'll do that, and then they miss out the whole path. It's like going on a world tour and missing out, you know, New York and Brazil and Singapore and Christchurch, and not doing, you know, it's that sort of thing. And I really do think they need to. Well, I think my advice is to them is to do it voluntarily, because the Commission and the US government and the Asia Pac governments are getting really worried about the amount of energy use that we're using as an industry. And you can only say that you're supporting other carbon change and climate change mitigation for so long before somebody's going to call you out on it and say, actually, you're not right, mate. You know, we're already under the targets. Yeah, we've got, you know, Greenpeace have done many things. How dirty is your data? How clean is your click? You know, they've been quiet for a while. You're pretty sure they'll be back into scope. The Sunday Times has done it, BBC, Radio 4, you know, all sorts of stuff is coming online. The stuff that's happening in the Netherlands, I think, is really alarming, because they've met, you know, I think it's the Agricultural Association in the Netherlands, 30-odd thousand farmers and smallholders are rebelling against some of the data center construction projects. They're seeking clarification of who made the decision and why they were allowed to do that. So it's you know, we run the risk as an industry of becoming pariahs, but you know, without really, well, there is some foundation to it, to be honest, but we can help ourselves. If we wanted to, we could help ourselves, but we don't seem to be willing to do that. But maybe the things have changed.
Everybody's guilty. Every person in the country is guilty of not deleting photographs, not deleting YouTube videos, not deleting. Every day we're just storing more and more information, and that's every person in the country is guilty of it. Just while we've got some time, I might just mention another data center I was involved in called LuxConnect in Luxembourg, which was financed by the Luxembourg government because they wanted to attract IT into their country. And they were very forward thinking, and they actually built 4 tier 4 data centers in Luxembourg, which are the top spec data centers. Well, one of them they put alongside a thing called it was called the Kilowatt Plant, KIOWATT, Kilowatt Plant. And that plant cost about 10 million to build, which is why a normal co-location data center wouldn't have touched it with a barge pole, because a 10-year payback on it. But what that plant did was it used waste wood from the surrounding area to generate steam, and the steam was then used to heat the local area and to provide a cooling solution for the data center. John will explain more about how the steam was turned into chilled water, but it also generated electricity for the data center and electricity for the local grid. So this plant was a very, very sophisticated way of running a low carbon data center, but at a very high cost on day one. And it's only something like a government that would consider doing that. But that's another example of where you can build a data center in somewhere like Luxembourg and you can have a low carbon footprint if you're willing to spend the money. So it was running on waste wood from the district. It wasn't importing the wood from Canada or anything, and biomass from the area. And it's a very, very effective solution to heat the district and power and cool the data center. I just thought I'd throw that one in there because I haven't seen another one like it since, because of the capital cost up front, I guess.
Yeah, I remember doing some work in Australia back in 2013, and they'd looked at trigeneration. So that's where you use a CHP plant to produce both energy and cooling and heating. But the costs for them were beyond considering. But I actually think moving forward, we are going to have to get a little bit cleverer. And when I was on the course last week, I kind of said, if you had been a data center guy back in the 60s at one of IBM's first facilities, and you knew about their data center, and you walked into a data center today, you could walk into the same rooms and see the same components doing the same job, right? That's 60 years later. Now, but think about a car. If you go back to the cars of the 60s, the Ford Angulars, the Ford Zephyrs, the Vauxhalls, all those type of things, and compare them to today's cars and the efficiency of those cars back from the 60s, and look at the efficiency of the cars today, we've leapt forward in leaps and bounds, and yet the data center is still back where it was.
Well, that's why I'm so excited about immersion cooling, John, because it's the only thing that I've seen that could radically change data center design. You walk into an immersion cooled data center and it's quiet and peaceful, not like a normal data center where they're noisy and hot. That's the other aspect of it, the environmental aspect for the operators. So, it's the only thing I've seen where that's been a real proper departure. We've had things like in-row cooling come along and various other things like that. But fundamentally, the data center hasn't changed at all in the last 60 years, as you say.
Right. Unless there's any more questions, I'm going to wrap it up.